one, and then you have one more problem I'm going to show you, and then that's the one you want to put at the end of your assignment today, and then I'll give you the access code, okay? So you can sign in whenever Canvas opens up. All right, so what we've been doing, if you watch the video from Monday, is we've just been kind of dissecting apart either tables, like we have here, or charts, and then graphs, and basically learning how to read them, okay? So in this problem number one, it says Owen and Rachel are day traders. The value of their stocks in one afternoon is shown below. T represents the time since 12 o'clock. Okay, so this is very important information here. T represents the time since 12 o'clock. So if you look at our chart here, our graph, here is T. Okay, so this is the hours after 12 o'clock. So if you think about it, this is not 0. This is actually 12 o'clock. Okay? And then 1 hour after 12 o'clock is 1 o'clock. 2 hours after 12 o'clock is 2 o'clock, and so on. Okay? So again, this is how this graph is represented. Okay? So these are hours after 12 o'clock. So in other words, 12 o'clock is 0 hours after 12 o'clock. All right? Hopefully that makes sense on how to read this thing. So what we're going to do is just fill in some of the charts and answer these questions. So we'll start with Owen's. Okay? Or Owen's table here. So time since noon. So time since noon is 4. So we go to 4. And we want to know the value of Owen's stock. So we go up. The value of Owen's stock is 120. So we'll put his in red. Okay. Then we want to know at 7 hours after noon, the value of Owen's stock is 100. So it has dropped. Okay. So this is just practicing reading a graph. Now let's go ahead and do Rachel's. So time since noon, so 0. So 0 means it's actually 12 o'clock. What's her stock price for Rachel? It's 70. And then we got at 5 hours after 12, it is 100. Yes, 100. Okay, so that's kind of how we read this stuff going here. All right, so now let's go ahead and just answer these questions at the bottom. Whose stock is worth more at 4 o'clock, and by how much? Okay, so if you look, 4 o'clock, who's worth more, Owen or Rachel at 4 o'clock? And the answer is Owen's worth more. Okay, find the point of intersection. What does it represent? So your point of intersection was from your notes, but it's basically where the two graphs intersect, where they touch. So the point of intersection is here. So what does it represent? So this point is 6, 110. All right, so that's the point of intersection. Hold on, guys. People are starting to come in. Okay, so that's the point of intersection. What does it represent? It says basically 6 hours after 12, Owen's and Rachel's stock are equal in price. So they cost the same. Okay, so that's at 6 comma 110, which is this point of intersection here. All right. Okay, now it says find Owen's y-intercept. What does it represent in this situation? So let's look for Owen's graph. His y-intercept is where it touches the y-axis, which is the value of stocks in dollars. So Owen's y-intercept is 0 comma 80. And what does it represent? 0 hours after 12 or noon. Owen's stock price is $80. Okay, so again, this is just some practice from some Im3 stuff. Can we look at tables? Can we look at graphs and kind of interpret information from them? Okay, so that's kind of what I want you to be comfortable with. It's fairly easy, guys, if you had Im3 or if you saw the video from yesterday. Okay, so I want to get you, what we're going to do now is I'm going to go ahead and give you a problem to do on your own. All right, so I'll give you about a minute if you're still looking at this. Again, think of this as just like my notes. Go and do an example for you, okay? So I'll give you 1 minute if you still want to kind of glance at this. And then I'm going to post a problem that I want you to do on your own. And then we are going to come back. I'll let you know at a certain time, and I'll give you the access code, okay? So we'll just give you a few minutes or a few seconds now. All right, we got all 12 of you in here right now. Again, there will be a recording of this on Canvas when we're all done. So if you miss something, you can always go back to that recording. All right. Here's the problem I want you to do. You do not have to pretty much like copy all the questions down. You probably have to do the graph and the tables. All right. So just add this to the bottom of today's assignment. Okay. So I'll leave that up there. I'm going to go over this problem. You're going to add it at the end of today's assignment, not the notes, because some of you already turned in the notes. So you're adding it to Tuesday's task or Tuesday's assignment. All right? Yep.
What time do you have to turn the notes in by today?
11:59 p.m.
Okay, yeah, okay.
All right. Okay, so let's get this in. All right. So we have a situation where we have Bob and Sarah, the brother and sister. Bob is walking home from the library. Sarah is walking to the library. So here's Bob's function. Okay. D is the dependent variable. T is the independent variable. Okay. So T, if you notice in our graph here, T stands for time in minutes. Hold on, where is that? Right here, okay? So that means this is going to be my independent variable. So we have time. Let's do Bob in red. Time, and we're going to have it in minutes, okay? And then my dependent variable is D, distance. D stands for distance, which is the y-axis here. And we are doing it in miles, okay? Or meters, sorry. Okay, so D stands for distance. And that is in meters. So what we're going to do now is use our function to figure out this chart, okay? And how do we do that? It's pretty simple. We're going to take our time, plug it in for t, do the math. So we're going to evaluate something we practiced, okay? We're going to evaluate this, and then we're going to get our distance. So we're going to input 0, and we're going to get an output of distance. So let's try that. So it says d equals 250 minus 50, and then our t for this one is going to be times 0. Okay, so I'm going to do this math in my head. 50 times 0 is 0. 250 minus 0 is still 250. Okay, so now let's go ahead and instead of t being 0, we're going to do the same thing for 1. T is going to be 1. So we're going to multiply 50 by 1. All right, again, let's do some math in our head. 50 times 1 is 50. So we have 250 minus 50. 250 minus 50 is 200. Okay, and then we got one more. We want to plug in 2 for t. Okay, so 250 and 50 times 2 is 100. 250 minus 100 is 150. Okay, I'm now going to transfer this information onto my graph. So at 0 for Bob, I'm at 250. So 0, 250. Okay? And that makes sense. If you think about this, he's walking from the library and he wants to get back home. So he's far away from home when he starts walking at 0 minutes. Then after 1 minute, he's at 200. So he's getting closer to home. After 2 minutes, he's at 150. Okay? And this is what we have for Bob. All right, now we're going to do the same thing for Sarah. We'll put Sarah in gangster purple. All right, so Sarah, same idea. We have a distance and a time. So time goes here. Distance is still here. We're using the same info. Time is in minutes. And distance is in meters. But now we have a different equation for Sarah. So she's D equals 75T. Okay? But instead of T, we're plugging in time. So in this case, we're going to plug in 0 here. All right, 75 times 0 is 0. All right, now let's plug in 1. 75 times 1 is 75. Let's plug in 2. 75 times 2 is 150. All right. So again, Sarah is walking from home to the library. So this makes sense. So at 0 minutes, she's at home. She's 0 meters away from home. Okay, because she started at home. Now after 1 minute, she's 75. So 75 is about there. And after 2 minutes, she's 150. So Sarah's leaving home and she's getting further and further away from home. All right, so now let's just answer these questions. That's how you fill in those charts. Let's answer these questions. Label each line above as Bob and Sarah. Explain how you know which is which. Okay, so we kind of explained that. Sarah's going away from home and Bob's getting closer to home as time passes. All right, so I'm not going to write that in, but you get the idea. Find the point of intersection. What does it represent? So again, here's our point of intersection where the two graphs touch. The point of intersection is 2, 150. What does it represent? It represents both Sarah and Bob are 150 meters away from home after 2 minutes. Okay, so again, after 2 minutes, they're both 150 meters away from home. What is Bob's x-intercept? What does it represent? So we're looking at Bob up here. Bob is red. His x-intercept is 250. So it is 0, 250. Okay, I'm not going to write this in. I just verbally say it. This says that Bob is 250 meters away when he starts to walk. Okay, so he's 250 meters away from home when he starts going home. All right, so that's kind of how you fill this in. This is just getting you comfortable with graphs, functions, and equations. Hopefully this is not too bad. All right, I'm going to now give you the access code. Please fill in the access code stuff. All right. It's on the agenda. If you're still not sure how to do it, or if you have any other questions regarding Canvas, regarding the math, regarding anything to do with my class, stay on, and then I'll answer those questions. But access code for today is ball. Okay? Once you check that in, you are free to go.